Hello, fourth grade mathematicians. We have two learning targets today. Our first learning target is I can figure out whether a triangle is an acute triangle, a right triangle, or an obtuse triangle. And those words acute, right, and obtuse should sound familiar from last lesson when we figured out whether an angle was acute, right, or obtuse. And figuring out whether a triangle is acute, right, or obtuse is going to be very similar to how we figured out whether angles were acute, right, or obtuse in the last lesson. Our second learning target is I will understand that the sum of all three angles in a triangle is 180 degrees. And when I am given the value of two angles in a triangle, I will be able to figure out the value of the third missing angle. In our last lesson, we learned that an acute angle is less than 90 degrees, that a right angle equals 90 degrees, and that an obtuse angle is greater than 90 degrees. So here you see four different rays all meeting at a common vertex, which is point D there in the bottom right. We have ray DC, ray DF, ray DE, and ray DG. And I wonder if you can look at this and figure out which angle is a right angle just by looking at it. So I'm going to ask you to pause your video for a moment, just really closely look at the diagram that I just described, and try to figure out which angle is a right angle. Go ahead and pause your video. Okay, welcome back. So if you said that angle CDE is a right angle, you're correct. And a right angle equals 90 degrees. And also, you can see that angle CDE has that part square looking shape at the bottom, which also tells us it's a right angle. Now, if we keep focusing on ray DC at the bottom, and then think about what other ray makes an angle along with ray DC, that's an acute angle. So I want you to actually describe that by naming the angle, but look at ray DC at the bottom, and then we want to figure out what other ray forms an acute angle here along with ray DC, and then name that angle. So go ahead, pause your video, examine this diagram, and see if you can name that angle. Okay, welcome back. If you said that angle CDF, so the angle that's formed when you look at how far ray DC is from ray DF, or the amount of turn from ray DC to ray DF, which we call angle CDF. If you said that's an acute angle, you're correct. And we know that because if angle CDE is a right angle, and then you can see that angle CDF, there's less turn in that angle. So when we measure with the protractor, we'll find that that is an acute angle. It's less than 90 degrees because angle CDE equals 90 degrees and is a right angle. So angle CDF is an acute angle. It's less than 90 degrees. And so now I want you to think about this. If we look again at ray DC at the bottom, and we want to think about what other ray, other than ray DC at the bottom, along with ray DC at the bottom, forms an obtuse angle. And then we want to name that angle. So go ahead, pause your video and figure out which angle is an obtuse angle. So if you said that angle CDG is an obtuse angle. You're correct. And partly we know that because we know that angle CDE is a right angle and equals 90 degrees. And you could see that angle CDG is greater than angle CDE. So angle CDG is greater than 90 degrees. And an angle that's greater than 90 degrees is obtuse. So angle CDG is an obtuse angle. And we can prove all of that by using our protractor. So notice that I put the bottom middle of the protractor on point D, which is the vertex for all of these different rays. And then I've run the bottom of the protractor to the left along ray DC, which is part of each of the angles that we just discussed. And so now if we look at angle CDE, the one in blue, we can see it runs right through 90 degrees. So we were right. Angle CDE is a right angle. And if we look next, if we look at angle CDF, you see the ray DF in orange going through the protractor. Angle CDF is 60 degrees, and 60 degrees is less than 90 degrees. So by definition, angle CDF is an acute angle, because any angle less than 90 degrees is an acute angle, and angle CDF is 60 degrees, which is less than 90 degrees, so it's an acute angle. And now let's look at angle CDG. Again, because the protractor is placed on the vertex D and is running to the left along ray DC, we're going to start with that outside scale with that 0. Some people think of it as the top group of numbers to measure angle CDG. And we can see that we go from 10 degrees to 20 degrees to 30 degrees to 40 degrees, 50, 60, 70, 80, past 90 degrees, which was our right angle, CDE, to 100 degrees. And it's not quite to 110 degrees, it's maybe 2 degrees less, so about 108 degrees for angle CDG. And if angle CDG is 108 degrees, and we know that the definition of an obtuse angle is greater than 90 degrees, well, we know 108 degrees is greater than 90 degrees. So angle CDG is an obtuse angle. I want to talk about the word triangle. So the prefix or word beginning tri, when you see tri before at the beginning of a word, that means 3. And notice in the word triangle, we have tri in the beginning, so it literally means 3 angles. And the definition of triangle is a shape with 3 angles. And if you look at this triangle, again, tri means 3, you'll notice that it has 3 angles. It also has 3 sides. And you'll notice for each of the angles, I've put a little part circle to show where the angle is. So there's 3 angles. One angle is angle ECD. The other angle is angle CDE, right? Angle CDE. And the last angle is angle DEC. And I'll just mention it one more time. The first angle I mentioned was angle ECD. So that's 3 angles, triangle. That's what triangle means. All triangles have 3 angles. So we're going to be talking about triangles today. I want you to look at the top part in orange, and we already know that an acute angle is less than 90 degrees. That's its definition. That's what makes it an acute angle. An acute triangle has all 3 angles that are acute or less than 90 degrees. So in an acute triangle, all 3 angles are acute. all three angles are less than 90 degrees. Now look at in blue in the middle on the left, we have what we already know, that a right angle equals 90 degrees. And then on the right it says right triangle. And for something to be a right triangle, one angle has to be 90 degrees, which is a right angle. So if we have a triangle where one angle is 90 degrees, that's a right triangle, just like a right angle is an angle that's 90 degrees, that equals 90 degrees. And then look at the bottom. I don't know if you can tell that's purple, but in purple on the bottom left, we have that an obtuse angle is greater than 90 degrees. That's its definition. That's what makes it obtuse. And then on the right, we have an obtuse triangle, and that's a triangle where one angle is obtuse, where one angle is greater than 90 degrees. So if we see a triangle where one angle is greater than 90 degrees, meaning it's obtuse, then the triangle is an obtuse triangle. So let's see how that connects with the three angles that we started with angle CDF, with angle CDE, and with angle CDG. And I'm going to start by focusing on angle CDF. What I'm going to do is I'm going to draw a line segment from point F to point C, and I'm going to create a triangle that way. And now notice that we have triangle CDF. That's one way we can name it. We could also name it triangle DFC or FCD. It doesn't really matter how you do it, but we'll call it triangle CDF. Notice it has three angles and also now has three line segments instead of any rays. So you have line segment CD at the bottom, line segment DF on the right, and line segment FC on the left. I'm going to go ahead and draw a part circle to represent angle CDF, and you can see that in orange there. That shows angle CDF. And now I'm going to do the same things for angles DFC and angle FCD, and you can see those there and there. So now we have a shape with three angles for angle CDF, and if it's a shape with three angles, that's what makes it a triangle, because again, tri means three, so triangle means three angles. And we're going to work with triangle CDF. So in that triangle, I'm going to have to measure all three angles to figure out whether it's an acute triangle, a right triangle, or an obtuse triangle. So in triangle CDF, I'm going to have to measure angle CDF, that one with the orange kind of part circle. I'm going to have to measure angle DFC, that one with the part circle. And I'm going to have to measure angle DCF, that one with the part circle, to figure out whether it's an acute triangle, a right triangle, or an obtuse triangle. So to measure each of those three angles in triangle CDF, I'm going to use a protractor. I'm just going to show you how I find angle CDF, and then I'm going to go ahead and measure the other ones myself, and you'll just have to believe me that they are what I say they are. But notice we're starting at the vertex, point D. We ran the protractor along a line segment going to the left, so we're going to start at 0 on the outside scale. Whenever we set the protractor up, so it starts at the vertex and then goes to the left along the here line segment, we'll start at the outside scale. And I can see that this triangle, or the amount of turn in angle CDF is 10 degrees, 20 degrees, 30 degrees, 40 degrees, 50 degrees, it's exactly 60 degrees. So I'm going to write that for angle CDF, that it's 60 degrees, and that's how I write that right there. Now I'm going to measure angles DFC and FCD, or we can also call that last one DCF, and see how many degrees they are. And when I measured those other two angles, I found that they also measured 60 degrees. That means that each of the three angles is an acute angle, right? Each one's 60 degrees. So angle CDF is acute, angle DFC is acute, and angle FCD is acute. And when we have three acute angles in a triangle, we call that an acute triangle. An acute triangle means that all three angles are acute, or in other words, all three are less than 90 degrees. And in this case, each is 60 degrees, so each is less than 90 degrees, and this is an acute triangle. This is an acute triangle. I want to take a moment to notice something. Each of those three angles was 60 degrees, and if we add those three angles up, 60 degrees plus 60 degrees plus 60 degrees, we get 180 degrees. So the sum of all three angles in that triangle was 180 degrees. And one thing we're going to find is that the sum of the three angles in any triangle will always be 180 degrees. So just start thinking about that now, and we'll come back to that later. So now I'm going to focus on angle CDE. We already figured out earlier that was a right angle and therefore 90 degrees. I'm going to connect points C and E and form a triangle that way. So now that I've done that, I can see triangle CDE there. It really doesn't matter. You could call it triangle ECD, triangle DEC. Just need to kind of go in order one way or the other, but let's just call it triangle CDE. And I noticed that angle CDE in that triangle is a right angle. We already had figured that out. It's a 90-degree angle. So I'm just going to go ahead and label that 90 degrees. And here I have a theory about what the measurement of the other two angles, angle DEC and angle ECD, are going to be. If angle CDE is 90 degrees and all the angles together in a triangle have to be 180 degrees, and since we already have one angle that's 90 degrees, the sum of the other two angles should be 180 degrees, the sum of all the angles minus the 90-degree right angle we already have. So the sum of the other two angles should be 90 degrees when we add them up. So I see that angle DCE is about 41 degrees, and angle CED is about 49 degrees. So let's see if angle DCE plus angle CED does equal 90 degrees. Like I said, I thought it would. Well, 41 degrees plus 49 degrees does equal 90 degrees. And this shouldn't surprise you because I told you that in any triangle, the sum of all three angles, so when you add all three angles together, it should be 180 degrees. So now let's add the 90 degrees plus 49 degrees plus 41 degrees. And 90 degrees plus 49 degrees plus 41 degrees equals 180 degrees. So just like in our other triangle, the sum of these three angles is 180 degrees, which will always be true in a triangle. But back to what we were originally talking about, is this an acute triangle, a right triangle, or an obtuse triangle? I'm going to pause the video and try to answer that and then come back. So you pause the video. Okay, well, I noticed that one angle is 90 degrees, a right angle, and the other two angles are acute angles. They're both less than 90 degrees. And the definition of a right triangle is that one angle is 90 degrees, a right angle. So this must be a right triangle because one angle, angle CDE, is 90 degrees. And it's a right triangle. You're going to notice that the other angles in a right triangle are always going to be acute or less than 90 degrees because since the whole triangle is 180 degrees, when you add all three angles up, the other two angles have to add up to 90 degrees, so they'll both be less than 90 degrees. But anyway, the takeaways from this is a right triangle because it has one right angle. You could also notice that the other two angles are acute, and that when you add all three angles up, just like in the other triangle, they equal 180 degrees. So next, let's look at angle CDG, which we had already measured earlier and figured out it was obtuse or greater than 90 degrees. I'm going to form a triangle by connecting point C to point G and creating a third side and also three angles, making this a triangle. So earlier we had already measured angle CDG at the beginning of the video and we figured out that it was 108 degrees. And I remember we've already talked about that all three angles need to add up to 180 degrees, or they always will in a triangle, and we've already used 108 of that 180 degrees. So let me go ahead and measure angles DGC and angle GCD, and then we'll add the three angles up and determine what type of triangle this is. So when I measured angle DGC, I found that it was 35 degrees. And when I measured angle GCD with my triangle, with my protractor, I found that it was 37 degrees. Let's see if 108 plus 35 plus 37 add up to 180 degrees, as they should. And when we add them up, we find that they do add up to 180 degrees. If you don't trust me, do the math yourself. So as with all triangles, this triangle has three angles, which is what the tri in triangle means, three. And I can see that it has two acute angles, angle DGC and angle GCD, because both of those angles are less than 90 degrees. And it has one obtuse angle, angle CDG, which is 108 degrees, which is greater than 90 degrees. And we already learned that a triangle where one angle is obtuse, and again, this triangle that we just looked at had one angle of 108 degrees, so that was an angle that was obtuse, or greater than 90 degrees, is an obtuse triangle. So this is an obtuse triangle because angle CDG is an obtuse angle. So it's a triangle with one obtuse angle, which makes it an obtuse triangle. And we're going to see that, or you might notice that both of the other angles are acute, just like with the right triangle. That's always going to be true because since the angles add up to 180 degrees, we only have enough to make two acute angles. So that's how triangles always work. If there's a right angle or an obtuse angle in the triangle, the other two angles have to be acute. Now, let's just stick with this triangle for a minute. Let's make believe that we were given that angle CDG is 108 degrees, and we were given that angle DCG, DCG was 37 degrees. But let's make believe we were not given the measurement for angle CGD. So I'm going to get rid of that 35 degrees. There, poof like magic, the 35 degrees is gone. Would we still be able to figure out, without using a protractor and without measuring it, what the measurement for angle CGD was? And the answer is yes, because we know that all three angles in the triangle have to add up to what? Go ahead and pause the video and tell yourself or tell someone, then come back. Okay, all three angles have to add up to 180 degrees. And we already know the value of two of those angles. So if we add 108 degrees and 37 degrees together, the two measurements that were given, we get a sum of 145 degrees. So those two angles together are 145 degrees, and we know that the whole triangle, when we add all three angles together, that's 180 degrees. So how can we figure out the measure of the remaining angle, CGD, if we know that the other two angles add up to 145 degrees? Well, we know the whole triangle, the three angles in the whole triangle add up to 180 degrees. So I'm going to write that 180 degrees there. And we know that we already have two angles adding up to a total of 145 degrees. So to find the measure of that remaining angle, we subtract that 145 degrees that we already have by adding up 108 degrees and 37 degrees. So we subtract that 145 degrees from the total measurement of all the angles in the triangle from 180 degrees. And the difference is going to be the measure of that remaining angle. Go ahead and try to subtract this yourself. So pause the video and try to subtract this yourself, then come back. Okay, so welcome back. When you subtract 145 degrees from 180 degrees, you should have gotten 35 degrees, which means that, like we had measured earlier, angle CGD is 35 degrees. Now all three angles again add up to 180 degrees, as they must with every triangle. Now when I give you your exit ticket, the problems that you're going to see, or at least the first group of problems, are going to look more like this. So they'll have measurements for each of the angles. So I want you to look at those measurements, and I want you to pause the video and tell me what type of triangle this is. Go ahead and pause the video, then come back. Okay, welcome back. So I see that one of the angles is 52 degrees, which is less than 90 degrees, so that angle is acute. Another one's 59 degrees, which is less than 90 degrees, so that angle is acute. And the last angle is 69 degrees, which is less than 90 degrees, so that angle is acute also. So all three angles are acute, and a triangle where all three angles are acute or less than 90 degrees is an... The answer to the last problem was it was an acute triangle. So now let's look at this triangle. I noticed that, well, 38 degrees, that's less than 90 degrees, that's acute. Another angle is 32 degrees, that's less than 90 degrees, and that's acute. But one of the angles is 110 degrees, which is greater than 90 degrees, and so that angle is obtuse. And a triangle where we have one obtuse angle is what type of triangle? That's right, it's an obtuse triangle. So I'm going to have you take a look at this triangle, and then I want you to figure out, is it acute, right, or obtuse? So pause your video, figure it out, and then come back. Okay, welcome back. You should have said that because there's one 90-degree angle, which is a right angle, and a triangle that has a right angle is a right triangle, you should have said that this triangle is a right triangle. Go ahead and take a look at this one, pause your video, and figure out whether it's acute, right, or obtuse. Okay, welcome back. You should have noticed that one of the angles is 100 degrees, that angle is obtuse because any angle greater than 90 degrees is obtuse, and a triangle with one obtuse angle is an obtuse triangle. Go ahead and try this one. So pause your video, try it, and then come back. Okay, welcome back. So I think this one's interesting because if you don't read the numbers, that angle that's 91 degrees looks a lot like a right angle because, you know, a right angle is 90 degrees and this one's 91 degrees. But 91 degrees is greater than 90 degrees, so 91 degrees is obtuse, and a triangle with one obtuse angle is an obtuse triangle. Go ahead and try this one, then come back. Okay, welcome back. One thing I notice is that each of these angles, all three angles, each one is less than 90 degrees, so each one's acute. When we have three acute angles in a triangle, that makes it an acute triangle. And the last practice one on IXL we're going to do together is this one, so go ahead, pause your video, and try to figure out whether it's an acute, right, or obtuse triangle. Okay, welcome back. So I noticed that we have one angle that's 90 degrees, and we know that an angle that's 90 degrees is a right angle, and we know that a triangle that has a right angle, or a 90-degree angle, is a right triangle. So you should have chosen right triangle, like that. This is an example of the type of problem that you'll have on the rest of the exit ticket. This is still practice, so practice along with me. In this type of problem, you're going to be asked to find the value of the missing angle. So we're already given the value of angle BAC, which is 30 degrees, and we're given the value of angle ACB, which is 40 degrees. They want us to figure out the value of angle ABC. Just go ahead and pause the video if you remember how to do that, and then come back. Okay, welcome back. So we know that all three angles together need to add up to 180 degrees because in a triangle, it's always true that when you add all three angles, the sum's 180 degrees. And we're given the value of two angles, 30 degrees plus 40 degrees, which adds up to 70 degrees. And since all three angles need to add up to 180 degrees, if we subtract that 70 degrees from 180 degrees, we'll get the measurement of the missing angle. So angle ABC, the measure of that angle is 110 degrees, because when we subtracted the 70 degrees we already had when we added up angles BAC and ACB from the 180 degrees that we would eventually have when we added all three angles up, we had 110 degrees left, and that's how we figure out the measurement of angle ABC. It's 110 degrees. Now my next question is this an acute, right, or obtuse triangle? Why don't you pause the video for a second and think about that? Okay, welcome back. Well, I noticed that angle ABC is 110 degrees, which is greater than 90 degrees, which makes that an obtuse angle. And any triangle that has an obtuse angle is an obtuse triangle. So this is also an obtuse triangle. So triangle ABC is an obtuse triangle because it has an obtuse angle. So I want you to try this one on your own and then come back. So just notice that we have angles FEG. That angle is already given to us at 35 degrees. We have angle EGF, and the value of that angle is already given to us at 55 degrees. So we want to find the value of the missing angle, and then also classify the triangle as an acute triangle, a right triangle, or an obtuse triangle. Pause the video and then come back and we'll solve it together. But I want you to try it on your own first. Okay, welcome back. The first thing you should remember is that in all triangles, when you add up the three angles, they add up to 180 degrees. So to find the value of the missing angle, we just need to subtract the sum of the two angles we're given from 180 degrees. The two angles we're given are 55 degrees plus 35 degrees, which equals 90 degrees. And when you subtract this 90 degrees from 180 degrees, that gives us a difference of 90 degrees, which is the value of the missing angle. And 90 degrees is a right angle, and a triangle with a right angle is a right triangle. And we can check our work to see if we figured out the correct missing value of angle EFG here by adding up all three angles to see if they add up to 180 degrees. And when we add up those three angles, we see they do add up to 180 degrees. So we know that when we figured out that the missing angle's value was 90 degrees, we were correct. Okay, here's our last practice problem. It's triangle OMN. We're trying to figure out the value of the missing angle OMN, and then determine whether this is an acute triangle, a right triangle, or an obtuse triangle. Pause the video and give it a try on your own. Okay, welcome back. So my first step is going to be to remember that all three angles together need to add up to 180 degrees. And that if I subtract the sum of the two angles that I'm already given from 180 degrees, I'll find the value of the missing angle. The sum of the two angles that I'm already given, 50 degrees plus 81 degrees, is 131 degrees. So when I subtract that 131 degrees from 180 degrees, I'll find the measurement or the value of the angle that we've been asked to figure out. So when I subtract 131 degrees from 180 degrees, I'm left with 49 degrees, which is the value of the missing angle. we now have the value of all three angles in triangle OMN. Each of those angles is less than 90 degrees, so each angle is acute. When a triangle has three acute angles, it is an acute triangle. And finally, we can check our work to see if we subtracted correctly by adding up all three angles to see if they add up to 180 degrees. So the values of the three angles that we have here in this triangle are 81 degrees, 50 degrees, and 49 degrees. When we add them up, the sum is 180 degrees, as it should be, or as it should always be, for the sum of the three angles in any triangle. So we know that when we chose 49 degrees as our missing value, that we chose the right measurement or the right value. Just like in the last two math lessons, your exit ticket for this math video lesson is going to be attached to the email in which we send the video lesson to you. So now you should understand what our first learning target was. I can figure out whether a triangle is an acute triangle, a right triangle, or an obtuse triangle. Again, an acute triangle is one with three acute angles. A right triangle is one with one right angle, and an obtuse triangle is one with one obtuse angle. And you should also understand how to do the second learning target. I will understand that the sum of all three angles in a triangle is 180 degrees. We talked about that a bunch of times. When you add up all three angles, they always equal 180 degrees in a triangle. And when I'm given the value of two angles in a triangle, I will be able to figure out the value of the third missing angle. And we did that by subtracting the sum of the two angles we're given from the 180 degrees, which is the sum of all three angles in the triangle.